All right, we can get started now. So today we're going to be going over all of the sort of work that you're going to be working on this week. I thought I would start off with the Statcrunch assignment, and after doing that, then I'll do some typical homework problems, but specially picked ones that covers areas that you might have difficulty with. So I usually like to pinpoint common problem areas. So let's begin. So when you get to the Statcrunch assignment, what it's going to allow you to do is to review all the things you've done up to that point. And so let's get over to Learning Module 7. Let's get over here and Module 7. So this isn't a typical homework or quiz type thing that you do on MyStatLab. You can only access it through Module 7. And as you know, overview objectives, all fine and dandy, but there's never anything critical in there. It's always in the lesson and activities. Let's go into lesson. Now these are the screenshot instructions. So you know what you should do is right click and save that to your computer, because that's going to show you every single step on how to use the Statcrunch assignment to do the assignment. That's what I'll be demonstrating for you. Then you want to right click on each of these and save it. This is your data file. So Statcrunch is going to take the data from this file and import it into Statcrunch. So you don't have to enter the data by hand. Okay. And then, of course, right-click this one and save it. This is the Word document that you're actually going to be doing the work in, and this is what you'll be turning into me. Here's how to approach this. Think of this Word document as a report that you're doing for another class, and you want your work to look really professional. So you're going to be importing all this output and analyzing, summarizing the data, which is what we've covered up through this point. And this is that same document that was on the previous screen. But if you missed it there, you could get it here. But these are the three files you need. And of course, Statcrunch always shows you all the due dates here. So without further ado, now the screenshot instructions show one way to access it, but I'm going to show you the other way, which is actually easier. Here, let's see, we don't need that anymore. And oh, by the way, looking at our calendar, you can see that our first exam is next week. So those of you who have told me who your proctor is, thank you. It's the vast majority of you. There's just a few I haven't heard from yet, so hopefully you'll get to me soon, because I like to send those exams out usually by around Friday, the week before, so that way the proctors have it on file and it's there for you. Because remember, you can take an exam early. Like if you wanted to take it earlier, you could. So that's why I like to get it to the proctors, by Friday. And so you could, if you wanted to take it early, Monday, Tuesday, Wednesday, of course, Thursday, and you at very latest one day later. So essentially, you got flexibility to take your exam anytime during next week, just scheduling it with your proctor. Now, if you're coming to the on-campus proctored exam with me, well, that has to be on July 12th, and it'll be at 6:30 p.m. in Central 12. All right, so let's go ahead and put that away. And let's here's what I recommend you do. Now, I've already downloaded those files. So here's the Statcrunch file. And here's what I recommend. Have it on one side of the screen so you'll be able to refer to this as you're using the Statcrunch software. Now, it's showing you how to access it this way. What's a little confusing is the homework doesn't look like this anymore. See how it used to have all these on the side. Now these only show up when you click on the help button up at the top. But rather than do it this way, I'm going to show you what I think is an easier way. So what we do is, let's get over to the home screen on MyStatLab. And you notice Statcrunch is right there. It's one of the left links. Oh yeah, let's talk about the important left links here. What's the most important of all? Why, the learning modules, of course. Okay. The discussion board was just for doing your introduction, so hopefully you've done that already. If not, you can still do it, but let me know, because I'm not going to be going back there checking for any people doing it late, because it was supposed to be done the first week. Now, external links is important, because that's an easy way to join the live lecture. And of course, this is where you get the recordings of our past sessions. So this was our first one. I was showing you stuff, how to redo homework till you get 100% on it, and all those other typical problems on that you would do in the homework. And of course, I covered the things that you probably would have trouble with. For example, how to make the histogram on your calculator look just like the one being shown in MyStatLab. So if you haven't watched that recording, you probably should. Now let's get back here to the main menu. And so of course your homework and quizzes and your grade book, but there's Statcrunch. So this is how we're going to access it. So I'm going to click on that. And what we want to do is go to the Statcrunch website. Now, what we want is the very first one here. Select a file on my computer. So you've already downloaded that Excel file onto your computer. So we're going to click on that. Now, I downloaded it to my desktop. So what I can do is I can just drag that on over. Now, be careful. It's got to be the Excel file. If I drag any of these other files over here, it's not going to work. So I'll click and I'll drag it over. And by default, it has use first line as column names. So you want that checked because, see, it automatically puts the column headings in there. And that's all you got to do. Ignore all this other stuff. Just go right past it and then click on Load File. And that's the easiest way to do it. So that's why I'm showing it to you. Now, so let's do this. I'm going to set up my Statcrunch over here on the left-hand side. I'll get my instructions over here on the right-hand side. Now, there's that Word document. Okay. And I've got that over here. So I should probably get that opened up. Assignment Statcrunch doc. There it is. So these are the three things I'll be working with. This is the one. In fact, first thing you should do is put your name on it. Don't use my name now. Okay. And then, of course, it mentions all these things here that I've already explained to you. But this gives you the directions. Make a stem and leaf for the data for the SOU column. Well, over here, it shows how to make the stem and leaf displays. Now, here's something your calculator can't do. It can't make a stem and leaf. So, now that we know what we're supposed to do, let's just shrink that down. We just look at these two. So, let's just look at the instructions. It says click on graph and then stem and leaf. Well, that makes sense. But if you look at this, you're wondering, well, now what do I do? You go over here to the instructions, and it will tell you exactly what to do. Okay. Now, I'll click here. Then, as it explains here, you also want to select this Medford one also. Okay. And I can, if I'm on a Mac right now, so I'll press the Command key. On Windows, you press the Control key, as explained right here in the instructions. And that way it gets them both on here. Then you say, what do I do for this, this, and this? Just go over here, and it'll tell you. And what we want to do is we want to select none. We don't want any trimming of outliers. We want to see any and all outliers. In fact, that's one it's very helpful to be able to see that. We don't want to trim anything. And that's it. That's all you have to do, and that's explained here. Once you've got that, you just click on Compute. And look, you've got a stem and leaf. Now, here's the key thing I want to get across here is, now how do I get this into my Word document? Well, there's different ways, but I want to show you the easiest way. And this is helpful for you to know anyways. And that is, oh, let me see if my My parallels was cut. Yeah, my Windows is acting weird, so I won't be demonstrating it. But what I'm going to do on a Mac, as explained right here, I just do the Command-Shift-4, and then I can click and drag whatever it is I want to copy that's on my screen, and then I can just go over to my Word document, and I'm going to insert that by doing Insert and Pictures from File, and it's when I do that, it saves them to the desktop. I got to do that again now. Picture from File, and I got to select my screenshot and insert that. Now, because you want to make this look professional, you just resize it by grabbing the corner, what looks good, and all those empty spaces put in, let's get rid of those. We don't want to look tacky, so it looks nice just the way you like. Then you know, okay, good. Now, this is where you get to review what you learned. We're not just pasting pretty input just for the sake of that. You've got to interpret what this is telling you. So you answer these questions. Look at this, and what's the shape? And then you type that in. Now, you might be looking at this. You might be scratching your head. I see a lump here and another lump here. Does that mean it's bimodal? Well, it's bimodal if the two lumps are similar in size. Is this lump as big as this one? Not by a long shot. Okay. So more than anything, that's a tail. Okay, so it's got a lumpy tail. No crime in that. So a lumpy tail to the left, that means it's left skewed. And so you're going to be answering these questions. Now, do you suspect outliers? Well, in order to suspect an outlier, you'd have to have at least one blank row here. But we don't have any blank rows. In other words, there's no leaves in that row. So you'd say, no, I don't suspect any. But if we had blank rows, you would say yes. Now, of course, how we'll confirm whether we have outliers or not, that's covered when you cover chapter 3.5 with box plots. We're going to be making that later on in a later step here. Now, going back over here to Statcrunch, notice this right arrow. Because I selected both SOU and Medford, it does both. So you've also got this one done, and you'd be able to copy and paste that to where it asks for the Medford one. Okay. Now, you say, well, I'm done with this, so you can click there. You think, oh, no, it's gone. Not really. You can always get it back. Just click here, results hidden, and if I click right there, it'll open it back up again. So you can get them back if you want. Now, let's go to the Word document, and you're going to see, now, what else did they want me to do? Well, you're going to put in the Medford one here, answer the questions, and then it asks for a histogram. And you say, how am I going to do that? By just following these screenshot instructions right on the right here. Oh, by the way, as you're doing this, you should, at some point, hopefully soon, be sure and save your work. Save as, just remember where you saved it. You might put your name in it. And that way you know you saved it. Now, continuing on here, like I said, we're going to make the histogram. Just following these instructions, and I'm going to be making them for both SOU and Medford at the same time. So we're just going to click on Graph, go over to Histogram, and just like we did before, click on this one. By the way, you could hold the Shift key and click on that one. So just might as well do them both. And then let's see, now what do we do? Well, over here under type, instead of frequency, it would be a good idea to do relative frequency because one data set is bigger than the other. And using relative frequency or percentages makes them, so one isn't bigger than the other. They're going to be similar. It makes it easier to compare them with each other. So, but just following the instructions, you'll know to do that. Now, this is entirely optional, but I'm going to do it. The green line will show where the mean is. This will show where the median is. And this will allow us to review when is the mean smaller than the median and when is it larger? And when are they pretty much equal? That's, one of the important concepts that hopefully you covered last week. So this would allow you to review that visually. And you're wondering, now what else do I need to do? And going over here, apparently nothing else. You've got all that, and those are optional, but I'll demonstrate. You might find it helpful. All right, so this is for SOU. If I hit the right arrow, you can see what it looks like for Medford. Let's look at this. So once again, if I rest my cursor there, so the green one is the mean, and the red one's the median. So why is the mean less than the median? Well, remember what you learned last week. The median is resistant to skew. Does it look like we have a skew on the left here? It does. So if the median stays split, what happens to the mean? Remember, the mean gets pulled towards the skew, and also outliers if there's any. Well, we don't think we have those, but we definitely have a skew, so you can see the mean got pulled to the left. And you would be expecting that if you saw the values for the mean and the median. Well, when you saw with the stem and leaf that it was left skewed, then you should be expecting beforehand the mean to be smaller because it's pulled to the left, making it smaller. Well, anyways, how are we going to get this in there? As before. Oh, yes, now remember, use the snipping tool for those of you using Windows. It's a built-in utility and it allows you to snip an image just like I'm doing here, and it'll save it to the clipboard, and then you can just go to your Word document and paste, which is the Control-V. So it's just as easy to use. We'll do this, and I want to make sure I get the SOU showing in there, so I keep straight which one is SOU, which one's Medford, because I don't want to get them backwards. Now let's go back over here, and oh, I don't need that one anymore. So that way when I click on Word here, I get this. There we go. So let's do our insert pictures, photo file, and it's this screenshot. Insert that. Once again, let's make it that. We don't need it that big. That's silly. So let's get rid of those empty spaces that got inserted in there, making it look so it's something you're proud of. And you can pretty much expect your answers to be the same here as it was for the stem and leaf. Left skewed, no suspected outliers. Because remember, stem and leaf histogram essentially tell you the same thing. Okay. And then, of course, you'll do the same thing for Medford and expect your answers to be pretty much just what you had for your stem and leaf. Then, mention any observations or comparisons that you see between these two. So just whatever you observe. Now we want to get the descriptive statistics. And of course, over here, it shows you exactly how to do that. So let's do it. Oh, we can go ahead and close that. Remembering you can get it back if you want to by clicking here, results, and clicking there. So this time we got to click on Stat, Summary Stats, Columns. And we're going to select both, just like we have and everything else we've done. Whoops, let me hold on, Shift. There we go. Now I got them both selected. Actually, let me do it this way. Because the way I did it, I had them backwards. Not that that matters as much. Now, we don't want to select all of these. And now if I just click on something like mean, then standard deviation, you think, what, I can only get one at a time? No. I'll click on mean, and then I will hold down the Command key on Mac, Control key on Windows. So if I do that, I want mean and standard deviation and median and interquartile range. Those are the only four I really need. If you want to do some of the others, that's fine, but just know that these are the only ones we really need to analyze. Because remember, mean and median are our measures for the center, which represent the typical data value for that data set. And standard deviation and the interquartile range measure the variability in the data, telling us whether the data is all spread out or it's really compressed together varies very little or somewhere in between, but measures the variability. And of course, we're going to have to figure out what we're going to use for the center and spread, whether we get our first choice or second choice. Once again, concepts being covered last week and continuing on into 3.4, 3.5. So you may not have gotten that far yet. Now, as for all these other things, just ignore them. But, that's clarified over here. Okay. So you got all that. Let's go ahead and click on compute. So we want to get this into our document. Hey, notice the medians are the same. Means are a little different. Got your standard deviations. You can see one has a larger standard deviation than the other, and also has a larger interquartile range than the other. So you might reflect on that. So let's go ahead and get our summary stats imported in there. And resize to whatever looks aesthetically pleasing to you. Now, here's something I recommend. Before answering these questions, let's jump to number 4 and make the box plots first. In other words, you might be asking, and be a reasonable question, well, why didn't you put that beforehand? Yeah, I probably should have, but I'll mention it now. Go do number 4 before number 3. And so we're going to get the box plots. Now, you got to be a little more careful in following the instructions, a little more to watch out for, because we really have to get both box plots above the same number line, or we won't be able to compare the data sets with each other. Because the box plots, there's 2 really helpful things it does. One, of course, lets us know whether there's outliers or not, but the other one that's really great, and we're going to see it here, is it makes it real easy to compare their medians and interquartile ranges with each other visually. But both box plots have to be over the same number line in order to do that. In other words, don't make 2 separate box plots. But the instructions are going to show us how to do that. So let's go ahead and get rid of that, or stash it away over there. And so we go to graph and box plot, and we have to select both, but we've been doing that all along here anyways. Okay. And now, definitely we're using fences to identify outliers, of course. But I like to see them horizontally. If you don't do that, they'll be vertically up and down, which is okay. Nothing wrong with that. If you want to do those, you can. Not really necessary. But if you want to, because we already did it with the histogram. And going down here, now, and you'll see this over here. Now, this is important. Don't miss this. It'll really mess things up if you do. Use the same x-axis. That's what gets both box plots over the same number line. So that's very, very important that you have that. Checking that is probably the most important thing after selecting these 2. That you don't really have to draw them horizontally, but you definitely need to use fences. But that's turned on by default. All right, so with all of that, click on compute. And if they're both over the same number line, you know you did it right. So if it's got an outlier, it'll show as a dot here. I kind of wish they'd make it a little bigger so it's more obvious, but you see there's none here. So you know whether you have outliers and when you don't. But look, you can compare their centers, and the spread, the interquartile range, is the length of the box. So compare the lengths of the box. So one box is longer, and that means it has more variability. And you can say whether it's, are they pretty much the same length? Or is one significantly longer? So those are the judgment calls you'll make. So as before, grab this image and paste it in. And that would go right here. Notice I could do it this way. If I highlight all that and insert it, then it wouldn't insert all those lines in there. There it is. So I got that. And I said, well, I don't need it that big, for gosh sakes. So just whatever looks good. Oh, and I didn't mean to. There we go. And then, of course, you'll be able to answer those questions. But now let's go back to 3. So these are the important concept questions. So, and I'm going to go over to the tutorial DVD, which I hope you have by now. If not, you should give me your mailing address or pick it up on campus, because this is the easiest way to get them. Just click right there. And so what you're doing right here is you are applying concept question number 1. So let's go over this, because if you don't know this concept, well, you're going to be making a lot of mistakes on this assignment. Shape. So do we have outliers? Is it skewed? So look at the box plots to tell you have outliers. Use the histogram or stem and leaf displays to determine if it's skewed. Then you know whether you get your first choice, the mean, only if there's no outliers and no skew. So you can't have either one of those. But if you have either one of those or both, then you have to use the median to measure the center. Why? It does a better job of representing the typical data value. It's not distorted by the skew and outliers. Then for spread, what are you going to use? You say, well, I already know whether I have outliers or skew, and I know I get the first choice, the standard deviation, but only if there's no outliers or skew. If I have either one of those, I'll have to use the interquartile range. So that's how you know how to answer these questions here when they're asking you, what should we use to measure the center? And then explain your reason, as covered in that concept question number 1 we just did. Okay? And then, of course, you'll answer the rest of those questions. And then, of course, you will save your work. So going here, File, Save. And once you've done that, then as it explains right here, you can email it to me as an attachment. Okay. All right? So that's what you'll be doing. Now let's go take a look at some of the homework you're going to be working on this week. I can go ahead and close that. And that. Oh, yeah, we don't need this anymore. Whoops. Do that over there. Let's get our calculator up over here. See if it fell asleep on me. Oh, that looks good. All right, so let's go over here. And so what I thought I'd start off with is I'm going to do something from chapter 3.4. Let's go to homework. And in chapter 3.4, I want to do the first ones and talk about these z-scores. What the heck is a z-score? Well, it's how we standardize a data value. Now, this is something we'll be doing a lot of in statistics, because if you standardize a data value, here's some of the valuable things that'll do for you. One, it makes it real easy to determine if that is an unusual data value, and you can compare data values with each other that come from completely different populations. And you'll be thinking, wait, that's like comparing apples and oranges. You can't do that. Oh, yes, you can. If you standardize those data values into z-scores. And that's what we're going to be doing here. So I'm going to turn on my little digital pen here so I can organize this. So this would be the sort of thing you would do on a piece of scratch paper, because we're looking at babies born after a gestation period of 32 to 35 weeks. So I've got one population with gestation period of 32 to 35 weeks. So that's one population. And they have a mean weight. So their mean, so I'm going to use the population mean symbol. And you need to keep reviewing what these crazy symbols mean because we'll be using them all term. So that's 2,600 grams. And a standard deviation, so I'll do sigma, the population standard deviation, of 800 grams. While baby's born after a gestation period of 40 weeks, so that'll be another population. Let's call it the 40, whoops, what's happening with my pen here? 40 plus weeks. Now, so that's a different population because it's going to have its own mean and its own standard deviation. And they're going to give that to us. Let's see here. So their mean is 2,900. So you can see a different center and a standard deviation of 440. So a different spread. Now they're going to give us a data value from this population and one data value from this one, and then be able to compare them. How? By, well, we'll convert it to a z-score. So on this one, if the 35-week gestation period baby weighs, so this will be X from the population of 32, 35 weeks. It's 2,100 grams. And the 40-week gestation period, so let's do that with an X subscript 40 to represent it. And it weighs 2,400 grams. Now find the corresponding z-scores. Once you do that, then we'll be able to easily answer this question. Which baby weighs less? You might say, oh, that's easy. This one weighs less. Hold on. Relative to the population it came from. In other words, its gestation period. So just because this number is less than that, that does not mean it weighs less relative to its gestation period. In other words, both of these are below the mean, below the center. So which one is farther below? Well, it's hard to say because one has more variability than the other. Don't worry, the z-score will make it easy to answer that. So how does that z-score work? Well, here's the formula. You don't need to memorize it. It'd be on your formula sheet. So we'll do this for the 35. And here it's a pretty simple formula. Okay. What you do is you take your data value and you see how far it deviates from the center. And then that distance, you see how many times the standard deviation fits into that. Okay. So just plugging in these numbers, this right here is the 2,100 minus the mean of 2,600 divided by the standard deviation of 800. But here's something to watch out for. If you're a little rusty with order of operations, you shouldn't be because this class has a math requirement, and you should be very well aware of this. But let's go ahead and we're going to punch that into our calculator. Now, you may be new to your calculator, so that's why I want to do this. So the left parenthesis is right above the 8 key, so click your left parenthesis, put in the 2,100, then the subtract key, then the 2,600, right parenthesis, that's above the 9 key, divide 800. And that's the z-score. So we're going to write that in there. So this is a negative 0.625. Now let's go over here and convert this data value into a z-score. So we got our z. This will be for the 40. And so we're going to take this data value here, see how far it deviates from its center, and then that deviation will be divided by these standard deviation. In other words, how many times does this fit into that deviation? So we go over here, so that's going to be the 2400. And we're going to subtract the 2900. And we're going to divide that by the standard deviation of 440. And as we did before, use the parentheses. If you don't do the parentheses, your answer will be very wrong. If you don't believe me, just try it. You'll see. So let's do our left parenthesis. And 2400 subtract 2900, right parenthesis, and divide by 440. We double check, make sure I punch that in right. Looks good. And let's write that in. Oh, let's get back to blue. Oh, let me do my Z35 here and my Z40. So this is a negative 1 point. I'm going to round to the second decimal place, 1/4. So if I round this one off, it would be 0.63. Now here's what I want to show you visually is let's draw a little sketch here of a normal curve. Put this in the center there. And so remember, you got 1, 2, 3 standard deviations, pretty much got it all. I need to extend this a little more. 1, 2, 3. Now, these are z-scores, by the way. And so a z-score is 0 means that your data value is exactly equal to the mean. Well, that makes sense because if they were equal, this would be 0, and 0 divided by anything is 0. Now, if your z-score is a positive 1, that means it's exactly 1 standard deviation above the mean. If it were 2, it's 2 standard deviations above 3. Now, if it's a 1 standard deviation below, it's negative. So when your z-scores are negative, that's telling you that you're below the mean. So this would be a -2, that would be -3. So let's look at this. Where do our data values, or z-scores, land? Well, this data value, 2100, it's 0.625 of a standard deviation below. So let's see, that's 0.5, so 0.625 would be what, right about there? Whoops, I'm going to overshot here. So this is 1/2 of a standard deviation below, 0.625, probably be what, right about there? So that right there is our Z35. So you can see, oh yeah, so for its population, it was just 0.625 of a little more than half of a standard deviation below its mean. But what about this one? Oh, it's over 1 standard deviation below 1, so that's 0.1. So it's probably what? Just a little more, maybe about there, just eyeballing it. So that right there is where the z-score is for the one from 40. Okay. So this one, this data value is much farther below the mean. So that means which baby weighs less relative to its gestation period? This one, this data value. You say, darn, I thought this one was smaller. Well, it makes a big difference whether it's relative to the population it came from. Okay, so now we can answer these. So let me turn this off. Now, watch out for this because this could be a little tricky. The 35-week gestation period baby weighs how many? Now, don't put the negative sign in there because they're having you interpret that. Just how many standard deviations below or above. So the 35-week is Let's go over here. And they want to round to 2 decimal places. So that would be 0.63. Now, if I put a minus in front of there, it's going to mark it wrong. So don't do that. It's an easy mistake to make. I'll say below. Now, for all you know, when you do this, you might get a positive z-score. You never know what you're going to get. But those of you who get negative ones, watch out for that. And then over here, we're going to put in the, not the negative, but a positive 1.14 standard deviations below the mean. Well, let's see how we did. Good, we got it right. But if I put a minus in there, would have marked it wrong. Okay. Now, which baby weighs relatively less? Well, we said it was the baby born in week 4 does, since its z-score is smaller or farther to the left. Okay, so let's check that. Next question. All right, so that's why I want to cover this one to make sure, and so you can see that this is the sort of work you should be doing on your scratch paper before you answer it. So that's why I do these live lectures, so I can demonstrate how you should be doing the homework. I'm trying to set a good example for you. Now, what I need to do now is let me get rid of all my pictures here. There we go. Oh, I did a dot there, so I need to clear that too. All right. So we'll go ahead and let's do something from chapter 3.5. Let's get into 3.5. And I thought, let's do number 4 so I can show you how to make a side-by-side box plots on your calculator like this. Now, if you got your calculator, this would be a good thing for you to follow along with. I'm going to put the name brand into list 1 and the store brand data into list 2. Let me just hit clear here. Oh, my calculator fell asleep on me, so whenever it does that, I just have to reboot it. And there it is, which fortunately is easy to do. Scoot you over here. All right, so let's press Stat, 1 for Edit, and if you got any data in there, you know what to do. You highlight list 1, press Clear, and then press Enter. Now, let's go ahead and enter our data. Okay, now I am going to double check my data entries. Okay, good. So once again, same example for you. Always double check your data entries because that's all it takes is enter one number in wrong, and of course you're getting all the answers wrong. So always double check that. Now, so with these box plots, now this would be a good time to remind you on your tutorial DVD, you know the easiest way to know how to do stuff on your calculator? Get out your tutorial DVD. From the main menu, click on Technology, and you got your technology chart. Now you could watch a movie, Or probably you just click here and get the screenshot instructions. And then this will step you through all this instructions. So what I'm first going to do is check for these two pitfalls. So let's press Y equals. Now see how blank it is? That's perfect. But like over here, what if you had been graphing some functions? So if you had anything in there, you'd have to put your cursor there and then press the clear key to make it go away. So it's all nice and clear, just like you see over here. Wouldn't hurt to scroll down, double check, make sure nobody hit anything down here out of view. So you got that. Now you got another. So that's taking care of pitfall number 1. Now pitfall number 2 is, we'll check it by pressing Y equals. Whoops. Let me press second quick. Get back to the home screen. Now I'm going to press second Y equals. There we go. Now you see you got 3 plots here. They all need to be off. But like you see over here, you might have more than one plot turned on. And if they're of different types, you're not going to get anything to show up on your calculator. So when I ever do this in class, I tell everybody, let's go select choice number 4. Hit enter to select it. And that'll turn all the plots off. So if any of you had more than one plot turned on, it's okay because they're all turned off now. So that takes care of any pitfalls that could have messed you up. And then, of course, the rest of the screenshots are going to be showing you what I'm going to show you now. But just know that that's a very handy reference for you. Because, you know, there's a few extra steps to remember with the box plots. And you got to be good at it because I will be asking you to make them on your first exam next week. So keep practice making them. Now, what you do is you press second, Y equals. Let's just select 1 for plot 1. Now what you do is you highlight what you want and then you press enter to select it. On is highlighted, so we select that by pressing the enter key. Then press your down arrow key. Now to scroll down to the next line, how you do that is you just keep pressing the right arrow key. If I keep pressing it, that's what gets me down to this next line. This is what we want. So with that highlighted, press enter. Then you can press your down arrow key. We want list 1 in here. So if you didn't have list 1 showing, you would press the second key and 1, and that puts list 1 in there. Frequency is always set to 1. And for the mark, select this one and hit enter if it isn't already selected. Now that will make a box plot of the data in list 1. Well, we also wanted to make another box plot for list 2. So how do we do that? Well, you could do it this way. Just keep pressing your up arrow key until you're up here. So plot 1 is flashing, then press your right arrow key. So plot 2 is highlighted and hit enter. All right, now let's do the same thing for plot 2. On is highlighted, hit enter. Press your down arrow to get down to types and just keep pressing your right arrow until this one is highlighted and hit enter. By the way, never select this one, only this one. This one won't show you if there's outliers, so it's worthless to us. Press your down arrow. Now here we want to put list 2. So press the second key and 2. And frequency will be set to 1 and that for the mark. So we do have 2 plots turned on. That's okay if they're all box plots. That's what will get them to show up on the same number line. Now, your calculator is going to save you a ton of work by finding you a nice viewing window just by you pressing zoom and then choice 9, which is zoom stat. So you can just press 9. See, it found a viewing window. Now this is important. Press the trace key and it shows that line is the median and it tells you its value right there. If I press the left arrow, hey, that's the first quartile and the left whisker. Okay. Now, the left side of a box plot you're going to learn when you get to chapter 3.5 is the first quartile is the 25th percentile. And what's a 25th percentile? It's the data value of 21.5, where 25% of the data is less than it and 75% is more. And I press the right arrow. And by the way, it's telling me this is the data for list 1. This is your median, the 50th percentile, because 50% of the data is below it, 50% is above. And the median is 25. The right side of the box is the third quartile, which is the 75th percentile. So for the data value 28, 75% of the data is less than it, 25% is more. So these are all important concepts that you want to be thinking about and applying, which is what your homework is all about, applying these concepts. And the concepts you'll be learning in chapter 3.4, 3.5 is percentiles. You've got to know percentiles because we'll be using them throughout this course. So once again, what's the 75th percentile? You see, it's the data value where 75% of the data for that population or data set is less than, below, to the left. And then the right whisker goes out to the farthest data value. So we don't have any outliers in either one of these because you'd see a little dot off to the side otherwise. Oh, how do I do the same thing for this one down here? Just press your down arrow key. See, now you got list 2, and then you can see what all those values are here. Now, remember what we were looking at the side-by-side box plots in the Statcrunch? So here you compare the centers, and you can see this center, median, is farther to the right. And the interquartile range is the length of the boxes. Well, they pretty much look the same. It looks like if I shifted this one over, the lengths of the box would be the same. But you said, don't we come look at the whiskers? No. For the measuring the variability, you're looking at the length of the box, which is the interquartile range. And you'll learn about that, chapters 3.4, 3.5. The interquartile range is a measure of variability or spread. It's a second choice method, okay, and it's the range of the middle 50% of the data because, between this value and this value is 50% of all the data, and it's the middle 50% because you got 25% to the left and 25% to the right. Okay, so that's how you get that on your calculator. Now let's see. Do you think we can locate this? Well, let's see now. Does it look like this could possibly be it? No, because look at that. See, there's a big difference in the left whisker, so it can't be this one. And let's see about, now of course you can zoom in and we can see that this is going, so 10, 11, 12, 13, 14, 12, 14, 15, 16. So that looks like about 16. And let's go up here. And that's to 20. So that looks about right. And going down here, that goes to 21. That looks about right. That one's just a little more. And then going down here, 24, that looks right. That's a little more. This one's looking pretty reasonable. Yeah, this one looks like a good match. But if you want to put your mind at ease, you could say, well, I don't know, Larry, you didn't look at this one very well. Well, you can see that going here, that's 21. Well, 21's here, so it couldn't be this one. All right, so I found fault with this one. I could find fault with this one. Couldn't find fault with this one. So we only get one chance here. Final check. All right. Then, of course, you'll go ahead and answer the other questions in here. But I just wanted to make sure that you knew how to do this on your calculator. Now, after this, then you're going to get to Chapter 4. And first, let me talk about the big idea of Chapter 4. And to do that, I'm going to take a quick look over at the lecture notes. Now, the big idea in Chapter 4 is this is where we're taking data from the past to predict the future. And so from each observational unit in our random sample, we're going to get 2 measurements from it. So that's different. You're used to just getting 1 measurement. Let me press quit here and get clear. Okay. So let's just get in here. And so one measurement will be called the X variable, the other will be the Y variable. Now these are quantitative measurements. And let's suppose that one measurement, is this number and the other measurement is this number. Well, remember what you learned about with your coordinate axis. The horizontal axis is your x-axis, the vertical axis is your y-axis. So those are our variables. So if this one were 18, this were 64, you could, well, let's do this one right here. See that it can be plotted as a point. That point represents this pair of data that came from one observational unit, one individual randomly selected in the random sample. Okay. So that means we can make these scatter plots. And if the scatter plots looks like they have a pattern in there, then that means I could use this X variable to predict what the Y variable is. In other words, we want to know if we can predict the future. That's what we want to do. Now, our calculator will do all the math that's involved in finding this line that best fits those points, the line of best fit. And when it gives us that line, it gives it to us as an equation of a straight line. So this is something you should have, I know you've seen before if you have the prerequisites for this class, but y equals, and then you have something number in front of x. That number is the slope of the line. Then you have plus or minus some number, and that's the y-intercept. So here we can see, the y-intercept is a positive 1, and your slope is the rise over the run. So whenever it has a rise of 1, it has a run of 1, 2, 3. Back on the line. Up 1 over 3. That's the slope. Now, if this were the equation that best fits all the points, you would use this to predict the future. In other words, let's suppose that you're saying, okay, when x equals 6, what do I predict y will be? We'll just plug 6 into the equation, do the arithmetic, and you got your answer. So you would predict y would be about 3. Okay, so we're using x to predict y. So that's why x is the predictor variable, or the explanatory variable. Y is the one we're trying to predict, and its value is in response to whatever value you plugged in for x. So it's the response variable. And then I have an example in the lecture notes here where a chef was using this to predict how many bowls of the special hot soup that he's going to sell the next day, which would be great because then he would know how much to make in advance. He doesn't want to make too much because he has to throw out the excess. If he doesn't make enough, he has unhappy customers. So he would like to be able to predict. And so that's what you put this data in list 1 in your calculator, this data in list 2. And I'm not going to do this example because you can do this on your own when you go through the lecture notes. And this steps you through the whole process, showing you the keys you press and how to turn the diagnostics on if you're not getting the R squared and R. Tells you how to do that. You can even play a movie and it'll step you through all this so you can follow along. So that's why I'm not going to do that example because you've already got a movie for it. Now, so with that being the case, let's look at a homework. Now here's something that's a little different in this homework is that in some of them you're going to be using Statcrunch, but in others you're going to be using your calculator. And so that's kind of what I want to get clarified for you. So let me just let you know now. When you're doing chapter 4.2 homework, just use your calculator because you need that practice, because that's what you're going to be doing on the exam. Because on the exam, you're not going to be using Statcrunch. You're just going to be using your calculator. But you're going to be doing some things your calculator can't do very well, or at least it's more complicated. And that is making the scatter plots and making the residual plots. That's when we'll use Statcrunch. But don't worry, you've got screenshot instructions showing you how to do it. Oh, let's get back in here. For some reason I jumped out. Why I do such a thing, I don't know. All right, so we're going to go over to the learning modules. So this is when you'll be doing module 8. Now, that's all well and good. That's all well and good, but the real important stuff is always in the lesson and activities. So you got the lecture notes that we were just looking at. But over here in activities, here's that movie that was also on that tutorial DVD. But here's what you really, really need. So right-click on this and save it to your computer, because this is going to show you how to use Statcrunch when you do the homework for chapter 4.1 and 4.3, which I'm going to be demonstrating for you. Now, I've already got this downloaded. It's how to use, Statcrunch, linear regression. All right. Now, the nice thing is, when you use this, it's going to load the data into Statcrunch for you. And this lets you know how that happens. So just like you, I'll have my instructions over here so I can easily refer to the steps I need to do as I do the homework. So let's go into the homework for chapter 4.1 and do number 7C, because it involves something that might leave you stymied if you're unfamiliar with it. Once again, I carefully pick which homework problems because I always cover the things that could easily mess you up. So let's get to the main menu, homework. Let's get down to chapter 4.1, and we're going to do number 7. Oh, look, it's already been done. Well, I'll fix that. I'm going to click on similar question. All right, brand new. Remember, that's how, if you get one wrong, you click on similar question and you can try again till you get 100% on it. And that's the nice thing about homework. You can, keep redoing it till you learn it. Now, so the important thing here is see that little icon? Click on that and then click Open in Statcrunch. So you don't have to enter this data in. Oops, it looks like I had a pop-up blocker here. Always allow. Okay. So let's try that again. Open in Statcrunch. There we go. So make sure you don't have any pop-up blockers, because that'll mess you up. Now we got that. And so let's go over, let's put this on over here. And this over here, so that way I can see my instructions. Now, what we're going to do, so this is pretty much what you'll do on all of these for linear regression. So let's go follow these instructions. We'll click on Stat and Regression and Simple Linear. Okay. And then we have the X order, I'll make that the first one, the age. And the second one in the column, I'll make that the HDL cholesterol. And you say, now what do I do? I'll go over here. Now, this has a bunch of stuff in here that you will not be doing. However, if you take my online Math 244, which is offered in the spring, you will be using all this other stuff. But that's reserved for the second term of statistics. All right. So, but all we're going to do, as explained here, is under graphs, we're going to click on the fitted line plot. Now, when you get to chapter 4.3, it's also going to have you do the residuals versus this. So you'd have to hold down on the Mac, the Command key or Control key on Windows, and click this, so that way both of these are selected. So even though I don't need this yet, I want to show it to you. I mean, you might as well have it generate. But that's all you'll be doing. All the choices you need to do, everything else just ignore. So tell which is the X variable, which is the Y variable, and then go down here, select fitted line plot, and that. And that's the most you'll have to do. Then click on compute. Now, of course, in recent, open this, say see everything. Now you see all this stuff here with p-values. Just ignore that. You won't be using any of that until you're in the second term of statistics. But if I click this right arrow, this is my scatter plot with the line of best fit in there. And if I click the right arrow, this is the residual plot. And you say, what's a residual plot? Well, imagine taking this line, tipping it over so it's perfectly horizontal. If you did that, now they don't show it here. What I like to do is I click and drag a horizontal line in there like that. So I've tipped over my regression line, and then it kind of put under a microscope to exaggerate the residuals, and you look for certain patterns. Okay, but this is what you'll cover in the last part of the chapter 4 lecture notes. But for now, I think the first thing they're asking about is the scatter plot. So let's scoot this over here. And let's see, which one does it look like it is? Now, they don't have the line in there. They just have the scatter plot. And so this kind of looks like the pattern here because you got those three up here, then this one and this one. Definitely not that one. Doesn't look anything like that. Doesn't look anything like that because this one, because the smallest one farthest to the left isn't the highest one. And certainly not that one. So I'm going to go with this one. Oh, good. All right, now let's continue on here. Now, let's compute the linear correlation coefficient. Well, Statcrunch did that for us. Now, be careful. You've got R and R squared. Now, they want R, and they want to 3 decimal places. Now, sometimes R is a negative number, so watch for that. If it's negative, you've got to make sure you get that negative sign in there. But this one's positive, so it is a positive 0.040. Let's check that answer. Good. Now let's continue. Now, does a linear relation exist between age and HDL cholesterol? Okay, now this is why I picked this one. Because if we go back up here, it has click the icon to view the critical values table. So let me tell you a little something about the values for R. And of course, you'll see more of this in the lecture notes. So this is the short version. Okay, so your values for R can only be within a certain range of numbers. So I'm using, so this is, it's going to be greater than or equal to -1, but less than or equal to +1. In other words, it can't be larger than 1. It can't be farther below -1. Okay. Now, if R equals -1, that means, I'll make a very rough sketch here. So here's X axis, here's your Y axis. So a negative slope means it goes downhill, going from left to right. And that's supposed to be a straight line, by the way. And if it's a -1, that means every point is exactly on the line. A perfect linear relationship. Couldn't be any better. Okay. So the negative means it's a negative slope going downhill from left to right, and it couldn't be any better. Every point right on the line. Well, that's pretty extreme. But the idea is, if it's a negative correlation, and the closer it is to -1, the stronger the correlation is. Okay. Now, what's a +1? Well, let me make a rough sketch of that. Okay, so positive slope. So that's a straight line. And if r, so this is an example of r equals -1. And if r equals a +1, that means every point is smack dab on the line. It couldn't be any better. So if it's a positive, notice it's going uphill from left to right instead of downhill over here. So every point smack on, it can't get any better, so that's why it doesn't make any sense for it to be bigger than 1. 1 is as good as it gets. Okay. Then the idea is, what's halfway in between these two numbers? 0. So the closer it is to 0, the worse the fit is. So let me just make a little sketch here. Let's suppose that it's just a hodgepodge of points. You don't see any relationship whatsoever. You see any relationship there? No. So that would be an example of r equaling 0. There's no correlation, no pattern in there. Okay, so where do you draw the line? How close to 1 do you need to be, or how close do you need to be to -1 before you say there's a correlation? Well, that's what this view of the critical values tells you. What you need, it varies, it changes depending on how many number of pairs do you have here. We have 1, 2, 3, 4, 5. So n equals 5, because we took a random sample of 5, and from each of those 5, we got 2 measurements from each one. All right, so let's go over here. And for n equals 5, our value for r would have to be 0.878. Okay. And what we say is the absolute value for r. So if it was a negative number, you would just take its absolute value. So our value for r has to be at least this big. 0.878. In fact, let's jot that down. So our critical value is 0.878. So once again, notice how it changes based on how many number ordered pairs you have. Okay, so we got that. I think we can go ahead and get rid of that. Now, so let's go down here. So let's look at our value for r. Our value for r is 0.04. Is 0.04 closer to 0 or closer to 1? It's way closer. But also, our value for r would have to be at least 0.878 or larger or closer to 1. Well, it's not even close to that. So not by a long shot. So we'll say there is little or no evidence of a linear association. So it's between A and D now, but let's see what the rest part is. Because the absolute value of r is less than the critical value. That's right. This one says there's little or no evidence because r is positive and greater. No, that would tell us, if that happened, that would tell us there is a correlation, association. So we're going to go with A. All right. So that's why I picked this one. So that's how you know where to draw the line. But this one was so obvious. It was obviously a bad fit. And that's what I would give you on the exam. I won't be giving you this list of critical values because it'll be so obvious. It'll either be obviously closer to 1 or -1, or it'll be obviously closer to 0. So you won't be scratching your head wondering. All right, so let's clear that. All right. Now let's do something from 4.2. So 4.2, we're going to use our calculator because we got to get some calculator practice here, and we'll get that in chapter 4.2. Let's get rid of that. And let's go down here. And we're going to go over here to chapter 4.2. And I think anyone will do. All right, so let's click here and look at the data. Okay, so you got X and Y, X and Y. So we'll enter that one in. Or let's look at one. Okay, let's do this one. The other one's going to take longer. We've already been doing it here for an hour and 15 minutes. I still got some more stuff to cover, so I think we'll be a little conscious of the time. And we'll get our calculator back up here. All right, so this is how you do it. You press Stat, 1 for Edit, and I got to clear these lists. Highlight L1, press Clear, and then Enter. Go over here, highlight L2, press Clear, and Enter. Now let's put the X data in list 1, Y data in list 2. Now you've got to get it in this order so that they stay matched and paired up with each other. And I'm going to double check my data entries. Okay, looks good. All right, so you enter that in. Now here's where you get the regression line. The least squares regression line, as they call it. So press the Stat key, go over to Calc, and choice number 4 for linear regression. Hit Enter. Now, we can tell it, okay, now where'd you put your X data? List 1, so press the second key and 1. Then the comma, which is right above the 7 key. Then our Y data is in list 2, so I press second and 2. Now I'm going to let you on a little secret. If you always put your X data in list 1 and always put your Y data in list 2, you don't actually have to put in list 1 comma list 2. You could leave that blank there and it will just assume that. It's a little time saver. Uh-oh, I don't have the R and R squared. Did that happen to you? Well, if it did, don't worry. We're going to turn our diagnostics on, and then it will always show us the R and R squared. And here's how you do it. We're going to get into this catalog. So to get into there, you got to press the second key and the 0 key. And you can just press and hold the down arrow key, because these are alphabetical order, all the different functions on your calculator in alphabetical order, and find diagnostic on. Get the arrow pointing at it. You'll have to press Enter to select it, and then press Enter again to run it. Now you will get the R and R squared. So let's see if that's true. Press Stat, press the right arrow for Calc. We want choice number 4. This time, let's just hit Enter. There you go. You got R squared R. And I didn't put in list 1 comma list 2 because that's what it'll assume. All right, now you can answer these questions. So Y equals, now the number in front of X is my A. So notice it's negative, so I better get that in there. So, well, let me scoot this so it's not covering it up. So I got a negative 0.851. Going out to 3 decimal places. And then the y-intercept over here, that's my B. That's the 6.894. All right, so let's check our answer. Good. Now, let's choose the correct graph. Now for this, now I will not ask you to make a graph or a scatter plot on the test. Okay, so for this one, you could go ahead and let Statcrunch do that for you. Oh, and as before, I wouldn't expect you to remember the steps, that you could just refer to those screenshot instructions that we had before. Okay, so we're going to go to stat, regression, simple linear. And this is easy. X variable is X, so Y variable is Y. Doesn't get any easier than that. Okay. And all we really need here is the fitted line plot. And let's get over to it. Now that we have that, let's scoot this on over this way so I can see that over here. So which one does it look like to you? Well, we've got, I think we can rule this one out. See how they're all either on the line or below? And over here, they're all above. So we know it can't be B and C. But what about A and D? Is there anything you could rule out? Well, let's see. This one looks a little suspicious. Doesn't this point look a lot farther below? And this point seems to be almost touching, whereas over here it doesn't. I'm going to go with D. Doesn't D look pretty good to you? And of course, remember you can hit on this to make it bigger. Yeah, that looks pretty good to me. I'm going to go with D. Oh, next question. Okay. So if it asks you to do a scatter plot, go ahead and use Statcrunch. But if it asks for the equation, yes, you could do this, but you really need to get some practice with your calculator. So really use your calculator on chapter 4.2 to give you enough practice with that. All right. And in 4.3, you'll be making the residual plot. But of course, I showed you how to do that on the previous one. All right. If any of you have any questions, be sure and ask them now, because we're going to be shutting this down here. Give you a chance if anyone's got anything they want to type up, you can do that. Let me think. Oh, yes, I do have something I want to mention. It's very important. So for those of you, who are kind of working ahead a bit, want to make sure that you take note of a very important learning module. Whenever we have a learning module right before a test, you know what it's going to have? Study guides for that test. It's going to have practice exam questions for you. Now, also your tutorial DVD. Let's click here on the main menu, and you'll notice practice exams. So you've got a practice exam number 1 along with the detailed solutions. So the idea is take this, once you've got everything covered, and you do a practice exam, make it a real simulation. Sit down where it's all quiet, you're not going to be interrupted, pretend like you're taking the test. Oh, and on this one, you can just ignore this first page. Really, you can. It's saying, I am going to have 5 concept questions from concept questions 1 through 16. You don't know which 5. So I said, well, you could do this. Use this random number generator to randomly select 5 numbers and let those be those 5. But this isn't anything you're going to do on the test. So you could really just ignore that first page. Here's your test. And you can see what your formula sheet is going to look like. Not much on there. You don't even need this first one because you're not going to calculate the mean by hand. But this is the z-score we used. And this is the one for the interquartile range that you'll see in chapter 3.4, 3.5. Right, so there's not much formula ways there, but that's why you can use your formula sheet as a piece of scratch paper if you want. Now let's suppose you want to learn from your mistakes. So let's suppose that you miss some. You say, boy, I'd sure like to have another practice test to see if I really did learn. Well, you're in luck, because in Learning Module 9, let's click on Lesson. So here it's telling you all the things to do. Review concept questions 1 through 16. Now if you're doing the homework correctly, these are the concepts you're thinking about and you're applying as you do the homework. That's what makes the concept questions easy to remember. If you've applied them, you have a concrete example of those concepts. They're just not some theory. You have applied them. And here's a nice chapter 4 summary. In fact, we should take a look at this. Because when people cover chapter 4, they say, boy, that felt like a lot. But when you look at the one-page summary, it doesn't seem so bad. So you'll find that to be very helpful. And of course, this exam one is the same one as on the tutorial DVD. But when you click on activities, guess what? There's 2 more versions of practice exams. So you could take a total of 3 practice exams if you want to. You don't have to, and these aren't anything you turn in. But make sure you do at least one, because that way you won't have any surprises on the test. Oh, by the way, here's that complete list of concept questions. This is the same thing you can get from the tutorial DVD on the main menu when you click here. Okay, so this is the easy way to get it from your tutorial DVD, but in MyStatLab, you can get it in Learning Module 9. Okay. All right, so, of course, the idea is that it'd be ideal if you got all of chapter 4 done this week, and that just gives you more time to keep reviewing for the exam. Okay. As you can see all these things you could be doing to make sure you really got it down. All right, well, let's see. Nope, no questions in the chat window. And of course, our next session, it's when it always is, Tuesday at 7:30 p.m. For this whole term, that's the way it'll be. All right, so we'll see you next week.